Let's have a look on this stack. Here in this problem we need to design a stack in which we have to do the 4 operations, inside which we have to do this 4 operations: push, pop, top. These are the 3 known operations to us. We have already studied this or executed this operation in the normal stack problem. But here came this function get minimum, which is new function. This is the extra new function which we need to implement in this problem. So, and we need to implement the solution with the big O of 1 complexity for each function. Means each and every operation of this function is to be executed in big O of 1 time complexity, constant time. Okay, so we will do this problem with 2 kind of approach. One approach is having big O of 2n time complexity, and we'll optimize it to big O of n later. Our big O of 2n solution. This is our big O of 2n solution. We have created the stack just before this min stack function. We do not have to write any or implement inside this min stack function. To implement this function given below, these are the 4 functions given to us: push, pop, top, and get min. Okay, so we have created the stack. Here, stack of pair of integer and integer value, the first value, and stack as we have created. And when we talk about pair, we also talk about first and second. Pair dot first, and this is pair dot second. So pair dot first is value and pair dot second is minimum value. And here we need to update the minimum value after each and every push and pop operation, and take care of this thing while pushing the one value into stack. S dot push, we push the value without any curly braces, but when we the pair of values, we push it with the curly braces separated by commas. Please do not make the mistake of pushing the 2 values inside this round bracket. Always push the pair of 2 values within the curly braces inside this round bracket. Every time we are pushing the pairs inside within the curly braces inside this push function. See, and for pushing the value inside the stack, we check the condition: is our stack empty? And if our stack is empty, so initially pushing the starting value. At the starting, we are having both value and minimum value, both we are having same value. So we have pushed the value comma value, and its else cases that our stack is not empty. Our if case was when our stack was empty, but now our else case is that when our stack is not empty. Now we are having some elements inside our stack. So So in this case we have to track our minimum value. Now our minimum will change, obviously, because there are many values occurring, so that's why. So to take out the minimum value, we take the minimum of value which is this value which we have pushed before, and the stack s.top.second, which is this one, the second pair. This is the minimum value. Minimum value represent stack.top.second. stack के top का second pair. And once we found this pair of once we found we get the minimum value, we push inside the pair of value comma minimum value this value. We push the value and this minimum value, and in the pop function we simply need to do nothing. We need to just do only s.pop, and in the s.top we only need to return stack.top.first, and make sure in the pop function stack.pop our whole entry gets popped, means deleted. Our first value pair and second value pair, means value comma minimum value entry, whole entry gets removed, and here in the stop function we will return the stack.top.first. Our first value of the pair represent the top value. We don't take here the second pair. Our first value is the top value that we have returned, s.top.first. Perfect. Now inside get minimum function we have returned stack.top.second. Second is our minimum value. Okay. Our pair's first value is the value, and our pair second value is the minimum value. That's why we returned here s.top.second. Now we will write the code for its optimal approach, big O of n.